Hey guys, welcome to Unit 7, Lesson 7, Unit Circle and Trigonometric Graphs. So let's get started with the do now. Before I even get started with the do now, I want you to understand that even if your angles are given to you in radians and you're comfortable working in radians, go for it. But I highly recommend converting all your angles to degrees, which would be easier for you to understand your question and work better. Okay, so again, I'm just going to quickly sketch my unit circle. We know a unit circle, the word unit means one. So unit circle is a circle with radius 1. So if this is a unit circle with radius 1, this is point is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. These are actually my quadrantal angles. Also, if I talk about it, 0, this is going in counterclockwise 90, 180, 270, and 360, and we can keep going on and on. But we're just making one complete rotation around the circle. So these are your quadrantal angles, right? How do they help us? Because we know our 0 and 1. Our x coordinate is your cosine value, your cosine angle at that point, and y is your sine value, right? So let's say if I said over here 1, this is cosine of 0 is 1 because cosine is your x. If I said 0, sine of 0 is 0. So this is how you read it, which we've done in the past lessons, but I just want to quickly go over this. Now it's asking us to, by using the unit circle, fill in the table below where each of the input angles is in radian measure. So since it's in radian measure, what did I tell you? The first thing was to convert it into degrees because it makes it so much more easier and you see the translation. So 0, I'm going to just go here, 0 degree, this is 0 degrees. Remember, pi is 180. So we're always talking in terms of pi, which makes it so much easier. So pi over 2 would be what? 180 over 2, which is 90. So that way you don't always have to substitute in the formula. And if you feel like substituting in the formula, then you're just multiplying it by 180 over pi or substituting pi with 180. It would give you the same answer. Don't put the pi in the calculator, please. So if I did this 3 pi over 2, I know pi over 2 is 90, so 3 times 90 is 270, and 2 pi is, again, pi is 180, 2 times 180 is 360. That's how I quickly do this without thinking too much about it. See, since we already did the right side of the zeros, the left is just negative of those angles, so this would be negative 90, negative 180, negative 270, and negative 360. Now, either I'm going to use this unit circle that I sketched up here to come up with these values, and you will see a pattern to it. I'm going to actually start at 0. So sine of 0 is, you literally substitute that theta with the angle that we are looking for. So that's what you'd basically do. So sine of 0 is, remember, sine is the y, sine of 0 is 0. Sine of 90 is 1, sine of 180 is 0, sine of 270 is negative 1, and sine of 360 is 0 again. So basically, if you reverse the pattern, that's how it goes. But if you want to look at sine of negative 90, which is same thing as 270, is what? Negative 1. Then sine of negative pi is 0. Sine of negative 270 is same thing as sine of 90, which is 1. And sine of negative 360 is 0. So do you see a pattern? It's 0, 1, 0, negative 1, 0, 1, 0. It alternates. Zeros alternate, and the positive and negative alternate too for ones. Okay, so now cosine is the opposite always. So cosine of 0 is 1. I'm going to do the right side. So cosine of 90 is what? 0. 180 is negative 1. This is 0, and this is 1. And I'm going to reverse the order. So a cosine of negative 90 is 0, negative 180 is negative 1, negative 270 is 0, and that is 1. So do you see how it alternates? So I just want you to also understand it. Wherever sine is 0, cosine is either 1 or negative 1. And vice versa. Wherever cosine is 0, sine is 1 or negative 1. And these things will help you once we get really in depth to graphing. Okay, So use the table to graph the sine curve on the graph below. So I'm going to try zoom in so we can see this. So if I did that, this is the sine, so I'm going to take the first two columns. So again, my angles are given to me, the increments on my x-axis are given to me in what? Radians, right? I want to convert them to degree, which makes it so much easier. So I'm going to write negative 360, negative 270, negative 180, negative 90. This is what? 90, 180, 270, and 360. It makes it easier for you to understand because I can see radians can be sometimes a little confusing for especially the first time when you're learning them. Moreover, I actually wanted to, hold on, I just want to get rid of this. I also wanted to talk about, look at all your sine values. Your sine and cosine values are between -1 and 1. Basically saying that your range of sine would be between 1 and -1, and same is for cosine. Your range of sine and cosine will be 1 and -1. So we'll talk about that in this question. So first let's use the table and graph it. So sine of negative 360 is 0. 270, negative 270 is 1. I'm not gonna scale it. I'm just gonna keep this one, and then this would be -1. What I mean by scaling is, like, I could have gone up above and done it. So this is 1, and then it's 0, -1, 0, 1, 0, -1, 0. I'm going to actually take a different color and sketch it. And if I use my freehand, please don't make it like V's. These are curves. This is like a very pretty curve. That's what it looks like, right? So now look at the domain and range, and I just graphed from negative 2 pi to 2 pi, but do you agree that if I extended it, it would go on forever? So my domain is your x values. Your domain is from -infinity to infinity, or as we say, all reals, right? I can write this or that. Your range is, what's the lowest y value? Your min comma your max. Your min is -1 to 1, and this would be hard brackets because -1 and 1 are included, and we just talked about that also. Another thing I want you to understand before we answer B is, look at your sine curve. I'm just going to highlight it. If I'm just going to trace the positive side of the sine curve, where is it starting? It starts at your midline, right? Would you agree that this is like midline of it? It's halfway of it, cuts the sine graph into half. So it started there, and then it goes where? To its maximum. Do you agree that 1 is your maximum? Then it went again to the middle, then all the way down, and then to the middle. So there's a pattern happening, and even if you go backwards, you see it, and that is very true. Your sine graph always, let's write this down, sine graph starts at midline. I can call that midline because that divides the graph into, here the x-axis is your midline, and we'll talk more about it as we go along, but it starts in the middle and it follows this pattern. Mid, then it went what? Max, mid, min, mid. Do you see it? It's following that pattern. So that's your pattern for your sine curve. And if you remember it, no matter what sine curve I give you, you will always be able to do it. Okay, so now it says, after how much horizontal distance will the sine curve repeat its basic pattern? So if you look at it, I went from mid, max, mid, min. I'm going to use a different color, so I'm going to start again. Mid, max, mid, min, mid. So how long was that? And then if I go again, it will be max. So it is 360 degrees. 360 degrees, or can I say 2 pi radians, right? So either or, it repeats after that. Okay, so let's go on to the next page. It's asking me to do the cosine graph. So here again, I know we don't have the value of tables, so if you can flip over to the back page, you can. So I am going to actually first of all convert my angles to degrees, my radians to degrees. This is 90, 180, 270 and 360, and this is negative 90, negative 180, negative 270, negative 360. Now we also know our maximum cosine value was 1 and our minimum cosine value was negative 1, so that's what my range would be. Now let's get started. I'm going to start at negative 2 pi, so or 360. What was cosine at 360? It was 1, so I'm going to go here. It was 1. I'm going to actually take a blue color. 1. Then at negative 270 it was 0. At negative 180 it was negative 1. Negative 90 it was 0, and that is at 0 it was 1, 0, 180 is negative 1, 270 is 0, and 360 is 1. So if I was to again take a smooth hand, please don't make any sharp edges. It's like a smooth curve. Oops, I'm just not going to do undo because it'll erase all of it. So it went from here. That's how your curve looks like. It's very smooth. That's your cosine graph. I can even write it. I didn't label the last one. Y equals cosine x. That's your graph. You can use the calculator also, but I'm not going to get into the calculator part till later. So this is what it looks like. And again, look at your domain and range, and you can just put arrows in the end. The domain is, if you look from the left to the right, it's going on forever, so it's negative infinity to infinity, all reals. Your range is from the lowest to the highest. Your range is from negative 1 to 1. You'll be like, the sine and cosine do have the same range and domain. Yes, they do, because they behave exactly the same. The only thing is there is a little shift happening, which we'll talk later, but it's just one little thing that changes them, but the rest everything, they're almost the same. Okay, so after how much horizontal distance will the cosine curve repeat itself? So again, it started at where? If I look at the positive side or the positive axis, it started at your maximum, then it went what? Mid, min, mid, max. Isn't that the pattern it's following? And that's like one full rotation. It's like 360 degrees. Where you started is where you ended. You started at max, you ended at max. So that is one full cycle, you can call it, or it starts repeating after that. So it is again 360 degrees or 2 pi radians. So I'm going to keep it in both ways. So here, that's what it is. That's one full cycle. Again, let's write down the pattern for cosine graph, which you see is what? It starts at max, then it goes to mid, then it'll go what? Minimum, then mid, and then it ends up at max. So do you see how it starts at max and ends at max? And your sine graph starts at midline and it ends at midline. So that's what it is. So these have a special name. A sinusoidal curve is the graph of the sine function in trigonometry. A sinusoid is the name given to any curve that can be written in this form. So don't have to memorize this, but we will be talking about each letter at every single day. The cosine wave is also said to be a sinusoidal, as it is a sine wave with a horizontal shift. It is literally shifted 90 degrees. So sine and cosine functions are the most popular of the trigonometric functions used for modeling, meaning used in a daily life. So now, today we are going to be focusing on our letter B in the sine function. We'll talk about A, C, and D later. Today we're going to start with, each day we're going to be doing a letter of the sine function. Okay, so when I wrote y equals sine x or y equals cosine x, your B is basically here, right here. That is the coefficient of x. So what was your B here? It was just 1 here, right? So B was what? 1 here. And B is actually called the frequency of your trigonometric function. So a periodic function, periodic means which repeats itself after a certain period, is a trigonometric function which repeats a pattern of y values at a regular interval. One repetition of the pattern is called a cycle. The period of a function is the horizontal length of one complete cycle. Let's examine the graph modeling the displacement of a pendulum. So it says, what is the period of the graph? What did we say? Period is something how, over here it says the period of function is the horizontal length of one complete cycle. So period means how long. It started at max and then I went down. How long did it take me to come to the same position? So that is your period, and which is corresponding value is what? 8. So it is 8, actually it's time, so it could be 8. You can write the unit also, it's 8 seconds. And now, how many cycles do you see it? So in this whole frame, how many times did it repeat, or how many times did it repeat? So it repeated one time here, that's 1. That's another 1, 2. It started at max, it ended at max. And then what is it? It started at max, but it ended at min. So it's a half, right? So it's 2.5 cycles. Okay? And I just want to, one of them, your period is, this is your P, period is your 8. And how many cycles is basically your B. So that's 2.5 cycles. This is what we're going to be talking on next page. So relative to y equals sine A, B parentheses x minus c plus d will, B will tell you the number of cycles. Isn't that what we said on the last page? Number of cycles, right? How many cycles? 2.5. So didn't I say B is 2.5? I'm going to just keep it like that. Number of cycles the graph completes in an interval of 0 to 2 pi. So with sine and cosine, we always focus on our 0 to 2 pi, that we are going to be working from 0 to 360. How many cycles are being completed from 0 to 360? That's why I did focus on, or when I was writing the pattern, I started at 0. Okay, the formula is the period of sine and cosine will be 2 pi over b. So your period, how can you find how long is something for? You do 2 pi divided by b. B is literally given to you in the equation. Or since I said I'm going to turn everything into degrees, so it'll be what? 360 over b, and it's an absolute value. It cannot be negative. Okay, so let's do this. How many full cycles? Again, how many full cycles means what am I looking for? I'm looking for my B of the function y equals sine 2x appear in 2 pi radians. Again, convert that. So in 360 degrees, how many cycles am I completing? So if I was to compare, I'm just going to compare my, what's in place of B? It is 2. So it's 2 cycles. So I'm going to complete 2 cycles. What is the period of the function y equals 5 sine 3x? I really don't care about the 5. That is something else. That's a different letter. We'll talk about it. I'm just talking about b. I know my b is 3. So I'll have 3 cycles in 360 degrees. But I want to find period. Period is what? It's 360 divided by 3, which is what? 120. Got this formula from here. We wrote that up here. Or if I want to work in radians, it's 2 pi divided by 3, which is just 2 pi over 3. You really can't simplify it. Do not put the pi in the calculator. I can't stress that enough. Now, the next one is, what is the period of the function cosine pi over 4x? So what is in place of b? Pi over 4, right? My b is pi over 4. Again, I like to convert my radians to degrees. So either you multiply by 180 over pi, that's one way of doing it, or you can just substitute pi with 180, which is what? 180 divided by 4, which is 45 degrees. So my b is what? 45 degrees. Means not 45 degrees, it's not degrees, it's just 45. Something 45. I'll have 45 of those in 0 to 360 degrees. But I want to find my period. What do we know? The formula for period is what? 360 divided by 45, which is 8. Or if you want to use your radians, 2 pi over 4. Then I have to have my angle also in pi over 2. You do keep change flip, so it'll be 2 pi over 4 over pi. The pi's cancel out. 2 times 4 is 8. So no matter which way you did, you ended up with the same answer, right? But again, if you're working in degrees, then your formula should have 360 over your b. If you're working in radians, then you should have 2 pi over the actual angle in radians, okay? So let's graph this. We have 2 questions to do. I want you to pause the video and see if you try to see if you can do these. So it says graphs y equals sine 2x over this domain. So domain is very, very important. It means I'm not going to have arrows, and I'm graphing only in this region. I'm not graphing anywhere else because it said 0 to 2 pi. So y equals sine 2x. So what do you need for your graph? So you need your b, you know, is, oops, I need a pen. So b is what? 2. I literally picked off this, right? And what do I know about my sine function? It goes from 1 to -1. So 1, -1. I know my radians. I'm going to convert them. This is 90, 180, 270, 360. I know my b is 2. How do I do that? It means that I will have in this 360, I will have 2 cycles of my sine graph. So I want to find, you always need, for graphing, you do need your period. So how do you find your period? You do 360 divided by 2, which is 180. So your one cycle is going to be 180 degrees. Sine, you start at your midline. So you're going to start at midline and you end at your midline. The first, right, that would be one cycle, would be completed in 180 degrees. So just watch this. Let's do this. So you're starting at midline. We wrote the pattern on the last page, right? It's 180 degrees. So how do I go? I'm going to divide this into 4 equal increments. So mid, max, mid, min. So mid. Do you see how I completed one cycle? That's how I do it. There's also a formula which I want to introduce you to. How do I find these increments? So you got your period is 180. So if you do your increments, how do you find your increments? Your increments are period divided by 4. So if I do 180 divided by 4, which is 45 degrees, isn't this 45? This is 90. This is 135. I'm just going up by 45. So that's how you find it. So I'm going to continue the pattern, and if I keep adding 45, it'll be 180. If I add another 45, it'll be 225, another 45, 270, and this would be what? 315 and 360. So I'm again going to repeat the same pattern. Midline, max, mid, min, mid. So sorry about that. So did we finish 2 cycles in 360 degrees? Yes. No arrows because my domain is restricted, and that's how you graph y equals sine 2x. So let's do the last one. It says y equals cosine 4x. So your b is what? 4, right? Your cosine function, again, I want to graph in 0 to 2 pi. So it starts at what? Your max. First of all, I need to find my period. My period is 360 divided by 4, which is what? 90 degrees. So my one cycle is going to be 90 degrees long. So in this, I'm going to have 4. 1, 2, 3, 4. This is how I kind of do it, right? Convert this into degrees. So this would be 90, 180, 270, 360. What else am I supposed to do? I did my period. I want to find my increments. You can choose to write it. It is what? Period divided by 4. So my period is what? 90 divided by 4, which is 22.5 degrees. So think about it. In order to have a full cycle, I need 4 points. So it'll be 1, 2, 3, and 4. And it starts at max, and this is what your graph will look like. And I'm going to continue the pattern all along. You can choose to write all the increments, but if you're not comfortable, because we'll explore more of them, you can just, and look, that's your cosine graph. And those are 4 cycles of your cosine function, and no arrows because the domain is restricted. So that's basically it, guys. You need to practice these, do your homework, reach out to your teachers because they can be a little confusing if we don't follow along. So good luck